Hello TaleForgers! In today's video we will focus on the important topic of physics in ECS. We will use the knowledge we have gained so far and improve the code we have already written. So let's get started! Before we begin, a small piece of information. I updated Unity to the new version 2022.3.17 F1, so I eliminated the annoying editor errors when working on ECS. I prepared a simple scene, I changed the background to Winta and arranged the elements in the hierarchy. Empty game object that organize the structure. I have also created ground prefab that will be used to test Rigidbody in ECS. It is prefab composed of several modular assets. Today we will work in player and ground prefabs. In first, we will set physics and collision, and in the second, collision only. I also changed camera to perspective for some in-game depth of view and adjust clip planes. First, before we start playing around with physics, we need to go to Package Manager and download the Unity Physics 1.0.16. Without this package, any change to entity physics will not be visible in the game. So let's wait for download process to finish. Now we want to import custom physics offering from Samples tab. For ECS, when we are dealing with custom physics, we use the PhysicsBody component, which we can modify from the code. In the ground prefab, we just need to add PhysicsShape, which is responsible for handling collisions. Of course, let's adjust the collision to the object, both size and center. Also set the bevel radius to 0.1 to round the edges a bit. Let's go into the player prefab and add two components, PhysicsBody and PhysicsShape. For the PhysicsBody, we'll leave the motion type dynamic since we want our fox to move. We can add smoothing if we want more accurate results. For our purposes, I will skip setting this option. Set mass, let's say, to 10. The linear and angular damping can be left as they are. We can skip the initial velocity, but it might be useful for bullets later on. Gravity factor equals 1. We don't need a multiplier for gravity. Let's go to the Advanced tab and check Override Default Mass. We want to block rotation in the Z-axis, so let's set the Z inertia to infinity. Okay, let's move on to the PhysicsShape. First, we want to adjust the size, center and bevel radius, just as we did in the ground prefab. Naturally, you can adjust the size according to your needs. Personally, I choose such parameters and I am satisfied with the effect of a soft overlap on the ground object. Let's see the result in the game. It looks good. Before we move on, I would like to invite you to support us on Patreon. Even a small contribution will help to develop the channel and the quality of the content present. Link in description. Okay, so let's go to the code. In the player movement job, let's modify execute method. First, add in physics velocity, player velocity parameter. We need it to modify actual velocity for player entity. And also add necessary using unity.physics. Now create two methods, set rotation and set velocity. Remember to add best compile attribute. Let's add three parameters to set rotation. Entity player, local transform player transform, player aspect, and 3 parameters to set velocity. Entity player, physics velocity, player aspect, player aspect. Let's remove the code for calculating new position and set position to player transform.position. Then copy and paste the rotation code into the set rotation method. Of course, let's call in execute set rotation and set velocity with the desired parameters. Now let's implement set velocity method. Introduce new variable float3 velocity linear equals new float3 player aspect.speed multiply by player aspect.movement direction player velocity.linear.y player velocity.linear.z. Of course, set component via ECB, pass player entity, and new physics velocity linear equals velocity linear. Let's clear delta time occurrences. Great! We implemented Rigidbody in ECS. Let's test it in the Unity editor. Press play, and as we can see, the player moves via velocity change. I invite you to Discord and other social media, links in the description. In the next video, we'll focus on the implementation of the jump. Thanks for your time, I'm glad you are with us and our community is growing. See you in the next video.